Hi, this is the poster presentation for my final project for CS330. The title is Training Web-Based Agents via Multitask Reinforcement Learning. So in this project, we would like to train reinforcement learner agents that can navigate the internet and perform a wide variety of non-trivial tasks. For example, booking flights. The agent environment that we'll use is called the mini world of bits++. And as you can see on the slide, each task is defined by a natural language goal at the top, embedded within a small HTML page. The actions available to the agent are mouse and keyboard commands. This is an interesting objective because it leads to many practical applications such as AI personal assistance or provide more accessibility to applications. It is also a challenging task as the action set is extremely large and at the same time the rewards are sparse, as the agent only receives something on successful completion of the task. Our approach builds on previous works such as the DOM-QNet, so called because the authors used a deep neural net to process the DOM tree of the web page and output a Q function. These types of architectures actually do a great job of representing the website environment. However, the previous works have also shown that the agents still have difficulties solving the most complex tasks that require multiple steps. So the question is whether we can do better in terms of sample efficiency and take full advantage of the multitask learning framework. Our idea is that the RL agent might have very little idea what the goal of the task is at the beginning of training, since the instructions are given in natural language. We can solve this by first learning a function that maps the natural language goal and web page into the required goal state. We can then use this to augment the input into DOM-QNet. With this function, we turn the training into a goal-conditioned RL problem, and we're also able to utilize methods such as hindsight experience replay. The diagram on the slide shows the two parts. We use a LTSM network with attention to learn the function for the goal state. This is actually a supervised learning problem. And then we concatenate the concurrent state and the goal state as inputs into the DOM-QNet to perform a goal-conditioned Q learning process. Both parts of the training are done on multiple tasks at the same time. The results are promising as we saw nice performance improvements from learning this goal state function first. On the simpler tasks, our model used fewer iterations to get to a reward of 1, as we can see in the plot on the top for the entering password task. On the more complex tasks, which require multiple steps, for example, the search engine task shown on the bottom plot, our model shows a positive learning curve versus the other model, which isn't learning at all. Our intuition for why this helps performance is that we've simplified the training process by splitting it into two halves. The first part is just to enable the agent to understand the task at hand, i.e. converting a natural language instruction into a concrete goal state. The second part is then learning to go from the current state to that goal state, and here goal-conditioned reinforcement learning and hindsight experience replay helps a lot with the training. In terms of further work, we would like to explore combining both the understanding and execution parts into one end-to-end process. And we also want to generate more experimental results. That's the end of this presentation, and thanks very much for listening.